All right, 9.3 is rational exponents. And rational in terms of numbers really just means it can be written as a fraction. So as far as a rational number, 2/3, 4/5, 0.2 can be written as 1/5 or 2/10, so that's fine, but like pi you can't write as a fraction, so pi is irrational. Anyway, that's just background. So an exponent of the form m over n, where m and n are both integers and n isn't 0, is a rational exponent. Rational exponent theorem, lots of stuff going on. I want to just write a couple things about it that will hopefully be a little clearer than all this stuff. So one thing we know, if you write something in the form x to the m over n, m is your exponent, n is your radical, or root, depending on how you want to say it. It's also true that you can write x to the power of 3 over 5 as x cubed to the 1/5 power, since 3 times 1/5 is 3/5, or x to the 1/5 to the 3rd power, since 1/5 times 3 is 3/5. That's the gist of that formula. Here's how we'll use it. So radical form literally just means it'll have radicals in it. Exponent form, or exponential form as I'll sometimes call it, means you only have exponents, no roots. So for part A in example 1, x to the power of 3/4, 3 is our exponent and 4 is our root. So we can either write this as x cubed 4th root, or 4th root of x cubed. I usually choose this top one just to avoid the extra parentheses, but they're both equally correct. So 4 to the x over 3 power, 4 to the x cubed root, or cubed root of 4 in parentheses to the power of x, 3 to the 4 over x, exponent root. So we can either write this as 3 to the 4th power x root, or the x root, sounds funny no matter how you say it, to the 4th power. And now we'll rewrite in rational exponent form, and you'll notice I'll call this exponential form. That's just what I'm used to, and again, it's equally correct. And so we're really just going to look for our base, which is 4, and then its exponent over root. So x is our exponent, our root is 3, so we get 4 to the x over 3. For this one, our base is x, so it's x to the power of 3, that's our exponent, over a root of 4. And it doesn't matter inside, outside, you're just looking at what's the exponent, what's the root. This next one, our base is 3, exponent is x, root is 4. We can use this technique to evaluate as well. And the key, the starting point, is which one do you know? And I'll show you what I mean in a second. You might hear my children in the background. I apologize if you do. So essentially, we have an exponent and a root, right? And 64 is our base. So 64 squared, I don't know what that is offhand, but I do know that 64 cube root is 4. So I'm going to write cubed root of 64 on the inside and the exponent on the outside. So this turns into 4 squared, which is 16. Now we have 100. 100 cubed with our exponent, I mean, I can do it. It's a bunch of zeros and it's kind of eh. So I'm going to do square root instead. So I'm going to put square root inside, square root of 100. I don't need the 2 there. If you put it there, that's fine. And then the cubed on the outside. So we get 10 cubed which is 1,000. Again, you start with which one you know. If you know both, you can go either way. Now we want to find the simple fraction equal to the following. Well, what you do first is factor out a 1 over some number. So whatever's on the bottom of the fraction, you'll just factor that out. So here there's a 2 on the bottom. 49 is our base. So I'm going to make this 49 to the, well, 1 over, and that's where our 2 comes in. So we have negative 3 over 2. If we ignore the 3 and the negative, we just pull out the 2, 1 over 2. And then we have the negative sign and the exponent to deal with, so negative third. Okay? And again, this will work because 1/2 times negative 3 equals negative 3/2. So it must be an equivalent expression. And now I know that 49 to the 1/2 is the square root of 49, which is 7. So we get 7 to the negative third power, which is 1 over 7 cubed. 7 cubed is 343. So we get 1 over 343 for part A. And again, feel free to skip steps in there if you can do that and still get the correct answer. Looking at part B, I see a 3 on the bottom of the fraction, so that's what I'm going to factor out. I'll keep the 64 over 729. Don't worry about the big numbers for now. And that is to the 1 over our 3. Need some brackets, makes it look extra hard, it's not that bad. And this is to the 4th power, because that's what we had left. And again, 1/3 times 4 is 4/3, so we're okay. Still an equivalent expression. So now I can distribute that 1/3. And this is actually 64 to the 1/3 over 729 to the 1/3 to the 4th power. 64 to the 1/3 is 4. 729 to the 1/3, if you didn't know that offhand, that's totally okay. It's 9, because 9 times 9 is 81, times 9 is 729, no big deal. To the 4th power. And 4 to the 4th, I'll be honest with you, this is a calculator kind of problem. I'm going to pull one out here right now. 4 to the 4th I could figure out, 9 to the 4th not so much. 4 to the 4th is 256. 9 to the 4th is 65, 61. If I give something like this to you without a calculator, you don't need to know 9 to the 4th. 4 to the 4th maybe, but not 9 to the 4th. So don't worry about it. As long as the logic makes sense, we're good. These get a little bit trickier. So we want to write 1/2 to the n over 12 power as a power of 2. So essentially what we do, we're just looking at the inside for now, what's inside the parentheses, 1 over 2. Well, 1 over 2 is the same as 1 over 2 to the 1st power. And we care about powers of 2, that's why we're doing that. So it's 1 over 2 to the 1st to the n over 12 power. But we also know that 1 over 2 to the 1st is 2 to the negative 1st power, and this is to the n over 12. So because of properties of exponents, if I multiply negative 1 by n over 12, that's our new exponent, so we have 2 to the negative n over 12. And it looks like times negative n over 12, so I'm going to rewrite it. Should not be times, definitely an exponent. There we go. And so that's an equivalent expression to this. Why do we want to write it that way? Because we're told, and it's just something we can do. Okay, so now for 1 over 9 to the negative 2/5, I want to write it as a power of 3. So I'm going to focus on this inside, and I can write 1 over 9. We're looking for 3 powers of 3, so 9 is the same as 3 squared. So 1 over 3 squared to the negative 2 over 5. 1 over 3 squared is 3 to the negative 2nd, and this is negative 2 over to the negative 2 over 5th power. If we multiply these exponents together, negative 2 times negative 2 over 5, the negatives cancel. We get 3 to the 4/5 power. So for these problems in example 4, honestly, the purpose is just to make it look a little bit cleaner. But again, it's really just the same expression. Example 5, we'll just skip it. So that's it.